Welcome to the video lecture on covering interior angles of a triangle. Here I would like you to understand the properties of the interior angles of a triangle and your success criteria is for you to be able to solve for missing values and angle measurements within a triangle. So we'll start off with some vocab here. There are two types of angles inside a triangle. The red ones are on the inside and the blue ones are on the outside. We have some names for them. If they're on the inside, we call those interior angles because the angles are on the inside, and the blue ones represents the angles on the outside, or the exterior angles, because they're on the outside. Make sure you're able to distinguish between those two. So let's explore the interior angles now. We'll start off with a straight line here, and we know that a straight line is made of 180 degrees. Now let's start bending the line. Okay, we bend one side, then we bend the other. Did you notice anything? Did you notice anything happening to that 180 degrees? No, nothing happened to that 180 degrees. Okay, the fact that we bend this, okay, or unbend it, in this case, bend, unbend, the angles remain the same. This is a branch of mathematics called topology. This is the way I can quickly prove that the interior angles of a triangle has to add up to 180 degrees. We know that there are three angles here: angle A, angle B, and angle C, and they all have to add up to 180 degrees. That is the reason why. So let's look at an example to solve for the interior angles of a triangle. First one, set up the equation. We know that the three angles inside the triangle have to add up to 180 degrees. So 32 degrees plus 48 degrees plus the x is equal to 180 degrees. Now we can solve for x. 32 plus 48 becomes 80. So what we're going to do is subtract 80 to both sides. Those can cancel out. Then you get x is equal to 100 degrees. This makes sense because if we plug in 100 back in here for x, the total within the interior angles would be 180 degrees. Now, what I would like you to do is solve for the missing interior angles here. This is time for you to practice. Pause the video if you would like to give this a try. So, 60 plus 40 plus y is equal to 180 degrees. We can now solve for y. 60 plus 40 is 100 plus y is equal to 180. Subtract 100 from both sides, you get y is equal to 80 degrees. Okay? Those were very simple problems, but now in this class we got to make sure we know how to set up the do harder problems, including ones with algebraic expressions. So here the example 2 is to solve for missing values of an interior angle. Here I'm asked to solve for z. We have 3z here, 2z plus 5, then 25 here. So set up the equation. Well, the equation is still the same. We add up all the angles on the inside, and that equals to 180 degrees. So 3z plus 2z becomes 5z. 5 plus 25 becomes 30. That equals to 180 degrees. Subtract 30 to both sides. You get 5z is equal to 150. Divide by 5 to both sides. You get z equals to 30 degrees. Okay? The setup is the same as before. You just have to be very careful with your algebra here. So now I would like you to practice number 4 and number 5. You're going to make sure you solve for the missing x. Please understand that the inside angles, or your interior angles inside a triangle, is 180 degrees. Pause the video and give this a try. Number 4, let's do number 4 here. We add up every angle inside the triangle. So x plus 3x plus 2x equals to 180 degrees. X plus 3x plus 2x is 6x on the left hand side. That equals to 180 degrees. Divide by 6 to both sides. You get x is equal to 30 degrees. On my right hand side, same thing. X plus 5 plus 2x minus 2. Then this square box means 90 degrees. So we add these three things together, that equals to 180 degrees. So I just simplify this by just getting rid of the parentheses. Okay, so x plus 2x, I made that in red. That combines. The 5 minus 2 and the 90 are all numbers, so those come together. So x plus 2x, that was the red, became 3x. 5 minus 2 plus 90 became 93. Okay, just be very careful with your combining like terms. That's why I color coded so you can see it much better. Subtract 93 to both sides, you get 3x is equal to 87. Then we divide 3 to both sides to solve for x. We get x is equal to 29. This is a typical problem for you to be able to do. So now we are going to grab the delta math problem. You're going to probably see it something like this. In this diagram, angle A is 62, angle B is 56, and angle C is equal to 82. Find the missing angle measurement of angle D, which is down here. Okay, you can assume lines that appear straight are straight. Okay, but the figure is not drawn to scale. So I have the image here on Paint, so we can work on it together. Please understand that our end goal here is to solve for this missing angle here. Okay, we're trying to solve for this one here. So let's try to figure out what we know. We know that this is 62 and this is 56. Right, and let's just make this a variable. Let's say x. Okay, so we know that 62 plus 56 plus x has to be equal to 180 degrees. So let's do that math. 62 plus 62 plus 56 is equal to 118 plus x is equal to 180. Subtract 118 to both sides, you get x is equal to 62 degrees. 62 degrees isn't what we want, but we know that this is 62 degrees. The fact that this is 62 degrees, we know that this is also 62 degrees, is congruent to 62 degrees because angle AEB is congruent to angle CED by vertical angles. Okay, we know that if this is 62, this is 82, and this is our question mark, we could set up the equation, right? We could say 62 plus 82 plus question mark. Well, let's just write a variable for it. Let's say angle D, right, is equal to 180 degrees, right? 62 plus 82. Okay, so 62 plus 82, this is 144, plus angle D is equal to 180. Now we can subtract 144 to both sides. So angle D is going to be equal to 180, subtract 144, gets you 36. Okay, so this angle here is 36. All right, so let's see if we are correct. Is this 36? Let's submit our answer. We did it correctly. Here, Delta Math shows us how we can do it. First of all, they got this as 62. They set it up right here. Because the total here has to be equal to 1, because the three angles inside a triangle has to add up to 180 degrees. That's the first step. Second step, vertical angles. Third step, we know that these two have to add up to 180 degrees. Okay, so this is a very good problem to show all the different properties. All right, there you go.